Hello and a warm welcome from your TeacherBot. All systems are functioning normally. Today's video is 249 data structures. I'd like to talk about M2 Lab 1. Now, we're going to be looking at searching in general. So the idea here is I have, let's call it a vector. I have an array, list, whatever you want to call it, of values. And I want to find the peak. I want to find the largest value. So of course, well, how could I start? Well, I could say here, I could go to OpenAI and I could just copy in my instructions and I could say, hey, write this program for me. Yep, okay, and that tells you absolutely nothing. So let's just close that. Let's talk about the problem. But I know that I know that you can always just go have the AI write it. What's that going to teach you? It's going to teach you how to push a button. So what I wanted to do is look at this warm-up problem. Okay, so this is just kind of an interesting question here. Because if we're going to find the largest value, well, what would be sort of the degenerate case, the smallest case? Let's just use three numbers. So I could say, here we go, I have 3, 4, and 5. So A is smallest because A is 3. Let's actually put a little message here. Let's say cout. And this is not even part of the assignment, so I'm simply showing you this because I wanted to think about the problem. Okay. All right, let's give it another run. This time I'll say, how about 4, 3, 5? So that way the middle one would be the smallest one, 4, 3, and 5. So it finds B as smallest. So what we see here is if I'm comparing three values with each other. So think about if I just compared two values, right? Well, I'd say is A less than B or is B less than A? Easy. But as soon as I get into, well, I want to know if A is smallest, B is smallest, or C is smallest. And this is only giving me sort of which one value is the smallest. So if I wanted to organize all three in order, which is just sort of a thought experiment, it's not the assignment, just something to think about. That's a lot of work, right? Because I've got to have an if statement for if A is smallest, and then what if A is smallest, and then B is next smallest. Okay, what if A is smallest and C is next smallest? You see, it's this what's called an explosion, a combinatorial explosion. There's all these different options. So we need a more generalized way to do this, right? So I'll just change this back to warm up, and I'll go to my main. So I wrote this program in class with our face-to-face students. So I'm going to walk you through what I did. I won't make you watch me type it in. But again, what you may choose to do is to type this in from the video, make some changes if you'd like. So here I kind of give the definition of a peak or a global maximum. In this case, we're just doing the global maximum, right? So I see here I say, well, 7 is a peak because 7 is greater than 4, greater than or equal to 4, and 7 is greater than or equal to 5. So that's the largest value. Think about if you have a classroom of like 4th graders and the teacher walks by with her hand out and says, okay, Billy, Susie, okay, Timmy's taller. Every time you raise your hand up, you don't bring it back down. So eventually at the end, your hand is at the level of the tallest student. I don't know, they used to do that when I was in grade school. So think about it like that. So we only need to keep track of one value, which is what's the biggest number we've seen so far. And once we've iterated over the entire array, well, then the biggest number we've seen so far is the biggest number of all of them. So this is the pseudocode I give, which is kind of similar to if you look at 2, 1, 2, 2, linear search. It's kind of like I want to find a particular value. Here we're just finding the biggest value. So given this vector, this array, compare each value in this array here with the current max. Now what should current max start with? I can start at 0, but then what happens if these values are negative? Because 0 is bigger than all of them, but it's not really a real value in the list. So what we might do is default to the first value in the list. That seems like a safe bet, right? So if the first value is not the biggest, it'll get quickly replaced, and if it is, then fine. So given each item, we go through, compare with current max. If the current value is greater than current max, update current max. So here I see it's 1, I get to 4, okay, now I change current max to 4. That's the biggest one. Next step through, I get to 7, 7 is bigger. Next step, I get to 5, 5 is not bigger, so we keep 7 in current max. And when we're done, current max is global max. So this is what OpenAI did for us, but it didn't explain what it was doing. So we're going to do it as follows. So first of all, I like using a const int for the size of the array. This is just so if we change the size later, we only have to change it in one place. You do not want the number 6 all over your code and you have to change it to 7, because what if there's other places you use the number 6 for something else? So here's my values. You can change them to whatever you want. So I actually added a CN. So let me turn this off for now, because we don't need this. You may add it if you want to play around with it. We'll use the default values. So start with the first value. We'll start with 1. And then we're going to loop through. Now, one thing you want to think about is how long does it take to run this code? You're going to read in the reading what they call on the order of. It's on the order of n. In this case, it's, okay, if there's 6 items, this loop runs 6 times. So if there were 7 items, the loop would run 7 times. Now, how many instructions? Well, it's this one line. Well, what if I added like a, cout, 1 potato, just to waste time? What would happen? Well, now, instead of running 6 instructions, you're running 12 instructions. But that's not really important, right? So the constant factor is what you ignore when you do big O. So we're saying this runs on the order of n. So as size gets bigger, this takes longer. So we're going to print all the values, so let's print these values here. And now we say we want to find the maximum. So the sort of C++ idiomatic way to say this would be to do a for loop. You could use a while loop. You think about in Python, what would you write in Python? So the Python equivalent would be, might say for item in list, right? And then next line, print item, something like that. And there's ways that you could do that in C++ too. But the idea is we're going to look at each item. We use I as a classic iterator. So starting with item 0, again, remember it's always 0 base. So this is item 0, 1, 2, 3, 4, 5. 0 to 5, 6 items. You want to remember 0 indexing whenever you count through an array. Same thing with a list. Okay. So we start here. The current value is 1 to start with. We print that out. And then we say if it's bigger, update it. And I have this line in here as a little bit of debug. So when we're done, the largest value is the current max. Now let's run this code to see how it operates. So it's a fairly simple program, but we want to think about why it works this way. Why does it take on the order of n operations where n is the size? Things like that. So we see 1, 4, now 4 is current max, 7, current max. 5, you don't update current max because 5 is not greater than 7. The largest value in V is 7. Okay. So now if you'd like, it's kind of optional, but you could add in the CN code and use your own values and see what happens. I'll just show you real quick, right? So let's say instead of the values listed, I'll put in some values. So one example would be, what's the case? Because I'm kind of curious, like how often does this if statement run, right? Because it only runs when the values are bigger. So let's say I'm going to do 0, 1, 2, 3, 4, 5. Well, what's going to happen every time the if statement is going to fire, right? So it's 0, then it's 1, which gets bigger, 2, 3, 4, 5. So interesting, right? So it's running the loop 6 times, and it's running the if statement 6 times. That doesn't really factor into the big O of analyzing the algorithm. We'll get to that later because it's additive. It's not multiplicative. Okay. So now I'm going to run it again with the numbers the other way. So I'll say 5, 4, 3, 2, 1, 0. Now notice this time it didn't run the if statement at all. It ran the if statement. It didn't run the code inside the if statement is what I mean, right? So it checks it each time, but then it's never bigger than 5, so it never goes down. All right. You can leave this turned on as CN, or you can change it back. Now, how do you want to submit this? Again, I want to make sure everybody's comfortable with this. So first, you want to take a screenshot. So what I use what's called snipping tool. And I just say here, snip this guy. Give me the code and the output. Let me try that again. Dragging with a laptop keyboard sucks. So let's just do it like this. Great. Okay. You know what? I'm not going to make you watch that. Get a mouse. Use a mouse. Sorry for that noise. All right. So you'll save this picture as M2 Lab 1. And then you can save this file as just main.cpp. And you should upload the screenshot and main.cpp. I'm going to leave it for there. So thanks again. And we will have more videos for you soon.